Hello students, welcome to the subject of complex variable and partial differential equation. Myself Dr. Ankit Acharya. And in today's lecture, we discuss about solution of first order or higher order partial differential equation by direct integration. This is the simplest method in this chapter, okay, where we can use using direct integration method and we can easily find out the solution, okay. Here you can see that left hand side we have only one term, okay, only one term and derivative with respect to x, with respect to y, higher order, second order, first order, whatever, okay. So in that case, one by one directly you can integration with respect to x, with respect to y. But the important thing is that whenever you are trying to integration with respect to x, okay, and in that case y is a constant term, okay, and that's why as a constant you have to add some function of y, okay. Similarly, suppose you are integrating with respect to y, okay, so in that case x is a constant, okay, and that's why as a constant term we have to add some function of x, okay. So let's see how we can solve this type of example. This is my first example, del square z by del x del y, that is equal to 2x minus 3y square, okay. Now the same term left hand side we have del square z by del x del y. So can I write this is exactly del by del x of del z by del y, that is equal to 2x minus 3y square, correct, okay. Now integration with respect to x, okay, on both the side, okay. So write down the full sentence, at least in examination, okay. I'm not writing the full sentence here. Integration with respect to x on both the side. So in that case y as a keeping y as a constant, okay, keeping y as constant, okay. And that's why we can add as a constant function, we can add some function of y. So that's why left hand side now we have del z by del y, and right hand side integration with respect to x only. So this is 2 into integration of x, that is x square by 2 minus 3y square is a constant term. So integration of 1, that is x, and let's say some constant, we have to add some constant, and that is function of y. So call it f of y, okay, clear. Now here this 2 will be cancelled out. So the del z by del y, that is x square minus 3xy square plus f of y. Now del z by del y, I just write once again, del z by del y, that is equal to, what is my function, x square minus 3xy square, okay, x square minus 3xy square and plus f of y, okay, plus I can say f of y. Now integration, now because I want the value of z, okay, so now next term is integration with respect to y, okay, and what is your constant term, x, keeping x as constant, okay, keeping x as constant. So that's why z, that is equal to integration with respect to y. So this is x square y, okay, x square is a constant term, integration of 1, that is y, then minus 3x integration of y square, that is y cube by 3 plus integration of f of y. So just write down, because this f of y is an unknown function, we don't know it, okay. So integration f of y dy and plus some function of x we have to add, so call it g of x. So this is my final answer. This 3 will be cancelled out, okay. So very simple, z is equal to x square y minus xy cube plus this integration of f of y dy. Instead of this term you can write capital F of y, where capital F of y, that is equal to integration of small f of y dy and plus g of x, okay. So this is your final answer. Let's solve one more example. Del cube z by del x square del y, that is equal to cos 2x plus 3y, okay. So can I write here, this is del by del x, okay, then del square z by del x del y left hand side, and this is equal to cos 2x plus 3y, okay. So now you can easily understand that first we have to integrate with respect to x. So integration with respect to x keeping y as a constant, keeping y as constant, okay, keeping y as constant. So del square z by del x del y, that is equal to, okay, first we have to integration with respect to x, y is a constant. So integration of cos with respect to cos 2x plus 3y with respect to x. So that is sine 2x plus 3y. In denominator we have coefficient of x, that is 2, and plus y is a constant, so plus f of y. Okay. Now once again we have to integration with respect to x. So just now we have del z by del y. I am not writing the whole sentence, but try to understand. Once again we are integrating with respect to x, keeping y as a constant. So now integration of sine, that is minus cos 2x plus 3y. Okay. In denominator now we have 2 into 2, so that is 4, plus x into f of y, because f of y is a constant, we are taking integration with respect to x, so f of y is a constant, plus g of y. Okay, and now once again now next is integration with respect to y. Okay, so that's why z is equal to, I can write z, that is equal to integration of minus cos, so that is minus sine 2x plus 3y minus sine 2x plus 3y. In denominator now we have 12, plus left hand side, what is my function? X into f of y, and now my integration with respect to y. So x is a constant. Okay, so x as it is, integration f of y dy plus integration g of y dy, and because your integration with respect to y, x is a constant, so you can add some function of x, that is called h of x. Okay, so this is my final answer for this example. Okay, now this example is quite interesting because this is initial value problem. So initial value problem means using some condition which is given in the example, you can easily find out the value of constant function. Okay, so what is my function? First of all, here just write down the equation once again. Del square z by del x del y, that is equal to sin x into sin y. Okay, so first I integration with respect to x, keeping y as a constant. Okay, keeping y as constant. Right now, del z by del y. So I can write del z by del y, integration with respect to x. So sin y is a constant function. Integration of sin x with respect to x. So that is minus cos x sin y as it is, and plus f of y. Okay. Now condition is already given. You can see that del z by del y. What is my del z by del y? Del z by del y is minus 2 sin y when x is equal to 0. So put this condition in this equation number 1. Okay, in this equation number 1. So left hand side, so using this condition we can easily find out the value of f of y. So left hand side we have minus 2 sin y. Okay, minus 2 sin y. Right hand side, put x is equal to 0. So minus cos 0 1. So minus sin y plus f of y. So what is the value of f of y? F of y is what? Minus 2 sin y plus sin y. So that is minus sin y. Okay. So I just write on the next page f of y that is equal to minus sin y. Easily you can understand. And now put this value in equation number 1. So what is my equation number 1? Now del z by del y, that is equal to minus cos x sin y. Okay, del z by del y, that is equal to minus cos x sin y and plus f of y. But now what is my f of y? F of y is minus sin y. Okay, so that's why minus sin y. Now integration with respect to y, integrating with respect to y, keeping x as a constant, Okay, so z that is equal to now integration with respect to y. Okay, so integration of sin y, that is minus cos y. Okay, so cos x cos y, once again integration of sin y, that is minus cos y. So plus cos y. Okay, plus cos y and plus integration with respect to y keeping x as a constant. So add some function of x, g of x. Okay. And now what is your next initial condition? Z is equal to 0 when y is an odd multiple of pi by 2. Odd multiple of pi by 2 means y, I can write y is nothing but 2n plus 1 into pi by 2. Okay. And x is 0. Okay. This is my initial condition. Sorry. Z is 0. Okay. Z, that is equal to 0. So z is equal to 0 and y is 2n plus 1 into pi by 2. So put this initial condition in equation number 2. Okay, suppose this is my equation number 2. So left hand side I have 0. Y is 2n plus 1 into pi by 2. So that means the value of y is like pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. And all at this angle, the value of cos is always 0. Okay. So this is cos 0. Once again, this is also cos 0. So 0 plus g of x. The value of g of x is 0. So that's why my final answer is z is equal to cos x, cos y plus cos y. Okay, clear? So this is my final answer, and in today's lecture we discuss about how we can solve the solution of partial differential equation using the method of direct integration. So thank you.